Today we're going to talk about central tendency. It can be a little confusing because central tendency is basically a number that we use to summarize data. And sometimes the central tendency is called an average. Now keep in mind that the examples of central tendency are mean, median, and mode. But a lot of times when we think of average, we think of mean, where we add up the numbers and divide by the number of numbers. Average in statistics does not necessarily mean that. It could be either mean, median, or mode. Now remember, the median is going to be the middle number of ranked data. We take the number of pieces and add 1 to it and divide by 2. The mode is going to be the piece of data that occurs most frequently. And the mean, of course, we add up the number of the values and then divide by the number of values. Now here we've got a stem and leaf diagram. The scores out of 50, and they want to find the median for the 11 boys and 11 girls. So if I take 11 plus 1 divided by 2, that's going to be 12. 12 divided by 2 is 6. So that means it's going to be the sixth piece of data. So I count them and I get to the boys is going to be 38. Now what I would like you to do is try to find the median for the girls. Again, there's 11 pieces of data. It's going to be the sixth piece of data. Pause and figure it out. Hopefully you decided that it was 26 for the median for the girls. All right. All we got to do now is keep in mind that when you're finding the median, you're looking for the middle piece of data. Take the number of pieces of data, add 1 to it, divide by 2, and that'll give you the place. If you end up with a 0.5, that means it's the average of the two numbers where you find. So let's take a look and find the mode. The mode for the boys. Which number happens the most often? That's going to be 38. Pause this and find the mode for the girls. All right, hopefully you did that, and hopefully you decided that the mode for the girls was 33. All right, now let's compare the results. If you look at the distribution of the boys and the girls, you can tell that the boys generally scored higher, which is also indicated by the median. And you also can tell that the data is more spread out with the girls, where the boys' data seems to be gathered generally around one smaller area. We would say the boys' scores are more consistent, and we would say that the girls' scores are more spread out or inconsistent. In this next area, we're going to talk about mean, and you'll take a look at the formula where it says x bar is equal to the sum of x times the frequencies, all divided by the sum of the frequencies. X bar is going to be the mean. More specifically, it's going to be the sample mean. Now, you don't have to worry too much about it, but pretty much in this class, we're always going to be dealing with the sample mean. When you get into another class, you may worry about population means, but we're always going to be dealing with sample mean. So X bar means sample mean. So first, the first question is how many first graders are in the group? We've got a list of times that the first graders juggled 2 balls, and we know that somebody did it for 10 seconds and it happened 3 times, and someone did it 11 seconds and it happened 5 times. How many altogether were there first graders? Pause this and see if you can figure it out. Hopefully you added up all the frequencies and you found out that there were 13 individual first graders altogether. Now, in order to find the median, we need the middle piece of data. There are 13 pieces of data. There were 13 first graders. And if I take 13 plus 1, I'm going to get 14. 14 divided by 2, that's going to be the 7th piece of data. So these are already ranked. The numbers go from 10, 11, 12, 13 to 14. So all I've got to do is find the 7th piece of data. Well, the 7th piece of data is going to be in this spot right here. It's going to be 11 seconds. There are 5 different numbers of 11, but the 7th one is an 11 also. So that's going to be our median. Now the mode is going to be the one that happens the most often. That is also going to be 11 seconds. Now in order to find the mean, what we're going to have to do is we're going to have to take all of our x's, 10, 11, 12, 13, and 14, and then multiply them by the number of times they happened, and then add those all up, and then divide by the number of times, or the frequency, the total frequency, which is 13. So what I want you to do is pause this and then try that and then start back up again and we'll compare. Okay, hopefully you did that. I'm going to go ahead and write mine out real quick. It's just the each x times the number of times it happens, the frequency, and then I'm going to divide by the total frequency, which is 13. And when I type that in my calculator, I'm going to get an answer. Now, the thing is, you can, type that in by hand, or you can use your calculator's stat function. If you push menu and then stat, which is number 6, and you're going to see a stat. You push number 1, which is one variable statistics. Then you're going to enter in all your x's and their corresponding frequencies. And after you get all those entered, you're going to push the option button. And when you push that, then you're going to push number 3, which is one variable calculations. And then you'll get all kinds of information. And one of them is going to be x bar, or the sample mean, which is going to be, in this case, 11.46. So keep in mind, you're going to always have to write out your method and show your work, but you don't actually have to add them all up individually. You can use the calculator to do that part. All right, take a look at this next one. The difference here is that the data has been grouped. We still have to do the same things. We have to estimate the mean. And keep in mind, notice the estimate, because we don't really know how many ages are 10 or 5. All we know is that between 0 and 10, there were 3 people. So when we have to find the mean and we're estimating with group data, we're going to use mid-class values. And I know that we get hung up about gaps or no gaps, but don't worry about it. Just take the two numbers and add them together and divide by 2. So in this case, the first mid-class is going to be 10 plus 0. 10 divided by 2 is 5. 10 plus 20 is going to be 30. 30 divided by 2 is going to be 15. 50 divided by 2 is going to be 25. 70 divided by 2 is going to be 35. 90 divided by 2 is going to be 45. And then 110 divided by 2 is going to be 55. Those are our mid-class values. Those are the values we're going to use to represent each class, because we don't really know how often any one particular number worked. And then what we're going to do is we're going to do the exact same thing we did above, and multiply the mid-class values times their frequencies, add them all up, and then divide by the number of total frequencies. Why don't you go ahead and pause this, try doing it on your own, and then compare your answer. All right, so hopefully you did that. We're going to take all of these and divide them by 30. And again, I would suggest you use the calculator and menu 6 and just enter in the x values, which in this case are mid-class values, and the frequencies. And after you've written down this work, you don't have to do all the calculations. You can let the calculator do the heavy lifting. You just got to be careful about entering the data in. So anyway, when I do that, I find out that the sum of all my x's is going to be 730, and that n is going to be 30. And so you'll notice I can also get this other information besides the actual number that I need, which is the mean, which is going to be 24.33 years. All right, now to estimate the median, this is a little tougher. We're going to do this a couple times. And just kind of bear with me. Basically, here's the process. What's going to happen is that we have to first identify which class our median is in. We're estimating, so we're not adding 1 to the number. The total number of numbers in this case is 30. And because we're estimating, we're just going to take 30 times 0.5, and we're going to have roughly the 15th piece of data. So now what I'm going to do is I'm going to go and look at the different classes and find out where the 15th piece of data is going to be. And if you see, the first class has got 3 pieces, and then the second class has got 13. The first 2 classes both added together have 16 pieces of data. So clearly the 15th piece of data is going to be somewhere in this class of 10 to 20. Now the next step is we're going to set up a proportion. And what we're going to do is we're going to figure out how far we went into that frequency, in this case of 13, and compare it to how big the class is, the frequency is, which is 13. And then we're going to set it up with a proportion with the class. Now the class starts off at 10, and we want to know how far it goes into the 10, between 10 and 20. And so we need to know how far to add, how many it goes into that class, and we're going to divide that by the class width. So basically it's how far I go into the frequency divided by the total frequency, and that should equal how far I go into the class width divided by the class width. So again, if you take a look, and I'm going to get rid of these mid-class numbers just to make sure that it's a little bit less confusing, and you'll notice that again I've used up 3 in the first class. So that means I've got to go 12 more into this frequency of 13. So I'm going to go 12 into 13. That's my first fraction. And then I'm going to make it a proportion. And now I'm going to make it equal to how far I go into the class width, which is x. I don't know what that number is going to be, but I do know the class width is going to be 10. 20 minus 10 is 10, and there are no gaps between the classes. So the total class width is going to be 10. So now all I do is cross multiply, and I get 13x is going to equal 12 times 10, or 120. And then when I divide both sides by 13, I find out that x is going to be equal to 9.23. Now, keep in mind, that's how far I have to go into the class width. And where does the class start? Well, the class starts at the number 10. So what I'm going to do is I'm going to take 9.23 and add 10 to it. And that's going to give me my approximate median of 19.23. Basically, like I said, what we're going to do is we're going to set up a proportion. We're going to do it again in here in the next one. So let's try this again. So now in number 10, they want us to find the modal class. The modal class is the class that happens the most often. So that's going to be from 10 to 20. It happened 13 times. All right, now number 11, we want to estimate the median. So what we're going to do is add up all the frequencies. We find out there's 23 pieces of data. We multiply that by 1/2 or divide by 2, and we get 11.5. That's roughly where our median is. We know that our median is going to be in this class because we've used 9 up before it, and so it has to be in here. We've used up 9, so we're going to go 2.5 into this 10, or this frequency of 10. So that's the first fraction. We're going 2.5 into 10. And then we're going to make it equal to how far we have to go into the class width. Now, we don't know how far we have to go into the class width, so we're going to call that x. But you do notice that there's gaps in this case, and so we have to change our starting point for our class width and our ending. This has got a class width of 10 and not 9 like you might think if you just did 20 minus 11. Now we're going to set up our other fraction. We're going to start off with x. We don't know how far we have to go in, but we do know that the class width is going to be from 20.5 to 30.5. So that's going to be 10. And so now all I got to do is cross multiply, and I get 10x is equal to 25. X is equal to 2.5. Now I know that I'm going to go 2.5 into the class. The class I need to go into is going to be the class that starts at 20.5. I want you to go ahead and find the mean for number 12 on your own. You're going to do it just like you did for number 8. As far as the gaps go, don't worry about the gaps as far as finding the mid-class value. If you add 1/2 to each side, it doesn't change the middle number. So, for example, that middle number for the first class is going to be 5.5. All right. Now in this next area, what we're going to do is we're going to be dealing with this formula of mean sample mean is equal to the sum of all x's over the number of pieces of data. What can happen is you can get problems where they give you this kind of information and you're going to use this formula forwards, backwards, and sometimes you're going to combine things. For example, in number one, basically what they want us to do is they want us to find the mean of two groups together. Now, let me tell you, unless the groups have the same number of things in them, taking the two means and averaging them will never ever give you the exact mean. It'll give you a close mean, but it'll never give you the exact thing. So basically what we're going to have to do is we're going to have to take the sum of all the x's for one group and add the sum of all the x's for the other group and then divide by the number of pieces of data or x's there are for both groups. In this case, the sum of all the x's for one is 1400, the other one is 900. Altogether, we've got 35 students. When we add those up and divide, we find out that the average is 65.71. Now, what I'd like you to do is pause this and try do problem number 2 on your own, and then start back up again, and let's see how we compare. Take a look at number 2. We have 19 rocks with a mean of 1.9. We got 14 rocks with a mean of 2.9. Now, they want the mean of all the rocks. So what I do is I take and I'm not going to ever add the means and divide by 2. That's never going to work. So what I do is I have to find the sum of all the x's for both situations. And you notice I can get the formula. I'm going to call one group A and one group B. So in this case, what's going to happen is that for the group A, I know that the mean is going to be 1.9, and I don't know the sum of all the x's, or a's in this case, but I do know that there's 19 of them. And for group B, I know the mean is 2.9. I don't know the sum of all the data pieces added together, but I do know there's 14 of them. Now, if I multiply 19 times 1.9, I'm going to find the sum of all those A rocks added together. And that's going to end up being 36.1. And then if I multiply 14 times 2.9, I'm going to get the sum of all those B's, which is 40.6. Those are the two pieces of information that I need. I'm going to add those two numbers. That's the sums of all those x's. And then I'm going to divide by the total number of x's, which in this case is going to be 14 plus 19, or 33. And that's going to give you an average of 2.324 kilograms. In number 3, we have a different situation. Basically, we've got 13 students who have thrown a softball, and we know that their average is 123 yards. Now, what's happened is a 14th student has thrown the softball, and instead of telling me how far the kid threw, they tell me what the new mean is. So they want to tell me to find out how far he went. So I'm going to break this down. I've got one mean of 123, and that was with 13 throws. I've got another mean with 14 throws, and that one is going to be, what did it say here? 121. Now again, the n is going to be 14. So now I'm going to take and I'm going to find the sum of all the x's for both of those. So if I take 123 over the sum of the x's of the 13 divided by 13, if I multiply 13 times 23, it's going to tell me the sum of those x's. And that's going to be 1,599. I'm going to do the same thing for the other mean. 121 is equal to the sum of the x's divided by 14. When I multiply those together, I'm going to find the sum of the 14 x's is going to be 1,694. Now, the difference between those two is how far that new kid threw the ball, which in this case was 95. So what I want you to do now is pause this and try number 4 on your own. There's 14 employees, but then there's a new 15th employee added. It's really similar. Figure out the new employee's hourly wage. When you get done, start back up again, and then we'll talk about it together. So just like the other problem, what we've got is 14 employees and we know their mean. And we have, let's see, 14 employees and we know their mean of their hourly wage is $14.50. So that's our mean. And of course, that's with n pieces of data being 14. Now, what happens is a new employee joins, and now the mean is lower. With 15 people, the mean is 1405. Clearly, the new guy is making a little bit less money than everyone else is. Now, again, the n is going to be 15. What I need to figure out is how much the new guy makes. So I find the sum of x's for each one. And in this case, it's going to be 203. And then I'm going to do the other one where I'm going to set up my mean of 1405. It's going to equal the sum of the x's, but it's going to be over 15. So my sum of my x's with 15 is going to be 210.75. Now, all I got to do is take the 210.75 and subtract the 203, and that's going to be the difference, and that's going to be the new guy's hourly wage, which is going to be $7.75. Take a look at number 5. In number 5, we've got a chess club, and they've got 12 junior members. And for the junior members, we know the mean age is 15.5, and the senior members is 17.6. Now, we want to find, in this case, they give us the sum of the ages of the senior members, and they want us to find the mean of all the members. So this is very similar to the other problem where we're going to set this up. We know the mean and the number. The difference is, in the other group, we know the mean, but we don't know the number. What we do know is the sum of all the x's. What I want you to do is I want you to see if you can finish this problem on your own. It's similar to ones we did before. See if you can figure out the mean of all the members. What you need is we need both of the sum of the x's. Start back up again when you're ready. Okay, so what we're going to do now is pretty much the same thing we did. We're going to take our mean of 15.5, and it's going to equal the sum of the x's over 12. And when I multiply 12 times 15.5, that's going to give me 186. That's the sum of those x's. Now, in the other case, I need to find the n. So what happens is it's 17.6 equals 528 over n. I multiply both sides by n and then divide by 17.6. Well, 528 divided by 17.6 is going to give me an n of 30. So now what I can do is take the pieces of information I have. To get the mean of both, I need both the sum of the x's, which is 186 and 528, add those together, and I need both the n's, which is 12 and 30. So 12 plus 30 is going to be 42, and when I divide those, I'm going to get a mean for both groups of 17. Take a look at number 6 and see if you can do that one on your own. Pause the video now and then try to do this one. Basically, we're just finding the mean of two groups again. And then when you're ready, start it back up again and we'll compare and see how we did. Okay, so hopefully you did that. We got two groups, two art classes. One art class has got 12 people with a mean of 48.7. The other art class has got a mean of 38, and it's got 7 people in it. Now, I'm going to call one class A and the other class B. It doesn't make a difference. I'm going to say that the mean of my A's is A bar, and that's 48.7, and the N clearly is 12. And then my mean of my B's, well, that's going to be 38.1. And again, my N for that group is going to be 7. All right. And then what I'm going to do is I'm going to write out both my equations and figure out the sum of the x's. So I've got 48.7 is equal to the sum of the x's divided by 12. And I got 38.1 is equal to the sum of all the x's divided by 7. Should be 7. I'm going to catch that a little bit later. Anyway, when I multiply both sides by 12, I'm going to get 584.4. And when I multiply both sides by 7, I'm going to get 266.7. I know what you're thinking. You're thinking I wrote 17. Yeah, I did, but I don't know why I wrote 17. The number is 266.7 when I multiply by 7. So anyway, now what I do is take both of my sum of my x's, and that's going to be 584.4 plus 266.7, and I'm going to divide by 19 people, 7 plus 12, and it's going to give me my average of 44.79. All right, now number 7, what happens is it looks a little bit weird, but it's actually a lot easier. They're basically giving me the sum of the x's, and they're telling me the number of pieces of data. So all I got to do is take the 960 divided by 60 and get my mean. In number 8, it says the mean test score is 78 or 0.78, and the sum of all the test scores is 24.18. How many students are in the class? And again, this is pretty simple. Pause it and see if you can't figure it out. Yeah, all we're going to do is fill in our formula. We've got 0.78 is equal to the sum of all the x's, 24.18, divided by n. I multiply both sides by n and then divide by 0.78, and I'm going to find out that my n is going to be 31. Take a look at number 9 and do that on your own and start back up again when you're ready. Okay, hopefully you did that, because this is just going to be, again, 2 groups. We've got one group 120, the other group has got 80. We know both of their means, and so all we've got to do is figure out their corresponding sum of their x's. And so we set up the equation. When we do that, we find out the sum of all the x's for the first group is going to be 3,147.72. And then the other group is going to be 2019.2. And see, now we have all our sum of our x's, and so all we've got to do is add those together and divide by the total number of minnows, which in this case is going to be 200. And when we divide by 200, we're going to find out that the average is going to be 25.8346. That's all for now. Thanks for watching.